All right. Welcome to my session for Modern Continuous Integration with Xojo. My name is Philippe Casgrain. I work at Lightspeed as a principal developer. It's a point-of-sale software that uses Xojo as main part of the interface. So before I get started, if you were at the last session, I want to say Chihuahuas versus muffins. So for your image detection. And my new favorite, Labradoodle or fried chicken. For it. So enjoy. Anyway, image detection fun. So what's the agenda for today? First, we're going to start with the way it was for Lightspeed on site, for how we were building stuff. I'll give you an overview of the IDE communication, how you can talk to the IDE. I will give you an idea of how to communicate with the socket via the command line. I'll show you how we use a shell script to control the IDE. What about debugging? And finally, I'll end with a before and after comparison that will be specific to on-site, obviously, but might show you some of the things that I've learned along the way. So really, this is all about how we improved the on-site build process from something that was very poorly written and hard to maintain to something that is much better and much more reliable. So specifically, we won't cover setting up the CI environment. That I gave talks about that before, but also it would take over this talk on how to do it. And we won't compare the different CI systems that are there. You may use BuildKite, you may use Circle CI, Jenkins, Bamboo. There's plenty of them. As long as they can be scripted, which they kind of have to be, you should be fine in whatever CI system you want to use. So let's get started. So basically, this is my fourth XDC, and when I came for the first one, I was talking to people. At the time, Lightspeed was probably the biggest software that was in use by Xojo, or that was built by Xojo, or using Xojo. And I gave an impromptu lunch session about how we were building on site. And when Greg saw the rigmarole that we were going through to build on site and all the different pieces that had to connect together and things like that, he took it upon himself to write a better way to do that. And now 4 years later, here I am, and I've implemented most of the stuff that Greg has put in the IDE. So what was it? Well, you know, a build script is usually just a shell script. So you start with a script. It could be a batch script if you're on Windows, or a shell script if you're on Linux or Mac. But in our case, we have a script called build client, which eventually calls build with Xojo, which is an AppleScript, and then which calls a build.rbs, which is a real basic script. So it uses XojoScript if you wish. Now the last part, I'm not going to change that much, because the build.rbs is a script that modifies some of the project properties, such as we're not a development build, we're a release build and things like that. So inserting a build number, things like that, that are not really germane to your specific build process. So my goal really was to simplify this whole thing into something that was much more understandable. So what is this build with Xojo AppleScript? Well, here's an excerpt of it. So basically what you can see is we use the application system events to be able to script Xojo with a certain timeout. And let's see if I can show my presenter notes here. There we go. Sorry about that. So you can see that the AppleScript itself is already a bit hacky. There's a timeout. That's usually a code smell of something that's going wrong with automation. I mean, sometimes you have to use a timeout. That's understandable, but it should be the last thing to do. If you look at system events, it means that we're trying to script Xojo using the UI to click on buttons and things like that. So I'm showing this to you as an example of what we did, but it's probably something you wouldn't want to do. The other problem with the AppleScript is that if you start with a shell script in which it has variables, like for example, what's the location of Xojo, which version of Xojo are you using, and such a thing, or which What's the build number you want to use? Is it release 123? Is it release 124, etc.? This information is hard to communicate between a shell script and an AppleScript and then a Xojo script. Like environment variables will work sometimes, but not always, and it's more complicated, especially when you introduce AppleScript to the mix. It's also, oh, I need to, where's my mouse? Because it's on that screen. How do I unclick this? Come on. There it is. Okay, now I can switch. So, this is also a security risk because in order to be able to use the system events, you have to go into your system preferences, accessibility, and give access to terminal to your system. So tell it, you can script my system. That's probably fine on a build machine, but if you could avoid doing that, that's probably better. And Apple has been, to their credit, ratcheting down the security, ratcheting up the security on these processes, so it's getting more and more difficult to do that. Really in macOS Mojave 10.14, don't know what they're going to do with 10.15, but basically if we can avoid doing that, it'd be great. So we're talking about communicating with the IDE. We can launch, there are some command line arguments that you can use with the IDE, like if you give it the path to a project, it'll open it when you launch from the command line. But basically, you want to do something that's better than just a command line that's just a fire and forget, or an AppleScript that's kind of hacky. So what's been there for a while is that you can do sockets. So whenever you launch the IDE, there's a socket that appears on your device. On the Mac, it's at /them/Xojo IDE. I don't know exactly where it is on Windows. Greg will probably tell you. But there is a socket, and that happens when the IDE is active. You can send commands to that socket. In the protocol version 1, which is the default protocol, it's a fire and forget. You send straight Xojo script as a ASCII essentially, or UTF-8 I guess, to that socket, and Xojo will hopefully do the things that you put in the Xojo script. And if there's an error, you don't know. The version 2 has two-way communication. So if you use the protocol version 2, which I'll get into in a moment, you can get two-way communication. So if you send a command, you can get a reply back that says if it succeeded or not and has interesting metadata on what happened, which is much more useful in a kind of a build/CI environment. The socket is also interesting because you can check for its presence. So if you're waiting for Xojo to launch, if there's no socket, it's still launching, right? Or if it hasn't been launched. So it's interesting to as a way to tell if Xojo is kind of ready to receive commands, if you wish. So we'll go quickly over socket version 1 because it's so simple. Sometimes that's all you need, and that, like, just to open a project, socket version 1 is probably okay. So basically, you send a string containing IDE script, which is a subset of Xojo script. The problem is if the IDE is already processing another script, like it's running a loop or whatever and things like that, or opening another project, you can send your command and it's just going to ignore it. It's like, it's gone, right? It's really a one-way thing. You won't get any information back. You won't get any info. What you really want is socket version 2. So JSON, or JavaScript object notation, is just a string that contains two pieces of information. There's a tag and there's a command. So it's just a dictionary that has tag and value and command and a value. And you send that JSON to the socket, and when the IDE sees that, it says, oh, I have a tag, so that I can use that when I send my reply, saying, this is a reply to that tag you sent. And then the command is the Xojo script command that you would have sent with the other one. In your Xojo script, I really recommend that you have it output something, like even just a print done or something like that. That way it'll trigger a response and you will be able to wait for it essentially, because you know that your script is supposed to return something, so you can wait on the socket, and then when the response pops back, you're ready to display it or analyze it or store it or whichever way you would do. It's useful to have some kind of output because otherwise you don't really know when a command is finished. It becomes kind of a fire and forget thing if you just do that. If you print something in your script and you run it manually, like not through the Xojo IDE, not through the socket, but you run it in the IDE, it'll actually display a message box. So that's also useful for debugging, right? So you can leave the prints inside of your script, and that is still useful. So Xojo ships with a sample application called the IDE communicator. You can modify it to suit your needs, build it, and use that version to drive the IDE. It's pretty straightforward. If you the very readable source code, you can take a look at it. But that becomes a chicken and egg problem. If you take IDE communicator and modify it to suit your needs, well, how do you build IDE communicator? Or how do you build your app? Do you have to build IDE communicator before you build your app? One thing you could do is you could have your IDE communicator, check it in as a binary, and say, I'm going to use that when I check out my code. I'm going to run this IDE communicator, and it's going to do all my work. Okay, that's great. You can do that. Typically, I don't like checking binaries because they're just essentially built files. But that is a simple way of doing things if you want to. And it is essentially a pragmatic solution for many people. I'm not going to go through that. I'm going to go through the solution that we implemented for on-site, which is all about having actual source code that we execute all the time. And you can see the source code, and you can diff it. You can have it reviewed and things like that, as opposed to having a binary which can't really be reviewed. It could be anything as far as the source control is concerned. The other thing about having a binary that's checked in is maybe that source code that you used to build it is somewhere else, and you can't find it anymore. So the only thing you have is that binary, and when it breaks, you're done, right? So since we want to do that, we'll want to use sockets and the command line interface. So we'll try to use the socket from the CLI so we can better integrate with our CI systems and have all these scripts that are just text files that are easily reviewed. You can, when they're modified, you can see the history of them and things like that. So I mentioned Windows briefly. The socket also exists, and you can talk to it using your favorite technique. I will show Python and Ruby here, which also exist on Windows. So in theory, you could do that on Windows as well. I have not tried that. I do not have a Windows system to test with. But essentially, if you use Windows, you can probably use the exact same technique I have here. Instead of a shell script, it's going to be a batch file, or directly a Python script for sure. But you can also start with the IDE communicator and see how it does there too. That should work fine. You can also make that communicator just a library and then link it to your program. All right, so going back to shell scripts and the IDE. I'm still going to go over socket version 1 because in some cases it's the right thing. It's the simplest thing you can do, and it works fine. So here I have an example of I'm just going to use the nc command, which -u, and what it does, if you look at the bottom here, nc-u. So I'm just going to take whatever the content of my variable here, build script, which is open file for that project, do the command build app, so that's your Xojo script, and then quit the IDE without saving. So that's my script. I'm just echoing it to Netcat, and here it goes. Pretty straightforward, works well. I can substitute, since I'm in Bash, I can substitute variables, which is very handy. I could have other variables above that describe what is the script path and the project name. So you can see I do variable substitution here. Pretty straightforward. Fire and forget. So this will build your app and quit the IDE without saving. And at the end, you should have a binary somewhere on disk that you can locate. So you'd have other ways of figuring out, oh, is Xojo done, for instance? I could have a process grep going, like I would wait for Xojo to quit because I could look at the process list and say, is Xojo selective? Yes, sleep a second. And keep going like that until Xojo quits, and then it's no longer active, and then I have something or not if there's a problem. So socket version 2. Since it's the same socket, just a different way of putting data into the socket, or a protocol, I don't have any ready-made tools on Unix that I could find that would do bi-directional communication with the socket. Like netcat is a, yes, send this string to the socket, but it doesn't care if anything comes back. I really want something that will do both, send a string and come back. Python and Ruby are pre-installed on Mac and are easily installed on Windows. They're pre-installed on Linux as well, if I remember correctly. At least Python is. And they do have socket support. So what we'll do is, and you will have this file as part of the slides, so this is an excerpt of them. You will have a file that I called ideconnect.py, and that's pretty simple. You'll have the entire file. You can look at it. Don't need to screenshot all of this. It'll be part. But basically, if you just look at it, I have some setting up here to say where my socket is. And this very important line here, I will send to the socket this little JSON string, which says, it's a dictionary. It says protocol 2, and then CHR0, which means end of file. So that when you do that to the socket, it says to the socket, whatever is coming next is protocol version 2. It's not going to be a straight Xojo script. It's going to be a JSON notation with a tag and a command. So that's the tiny bit that you need to do to activate protocol version 2, because it's the same socket. And here I have my tag, which is the command, and oh, there we go. So it's not. So it's there's two dictionary, the tags and the script. So this one is going to be tag is going to be command, and script is going to be whatever. I said tag and command. I meant tag and script. Sorry. So I will just dump the JSON, finish with a CHR0 to mark the end of the transmission, and then I'm going to wait for the socket to return data, and then I'm going to close the socket. Pretty straightforward. Yves?
What is that magic constant 4096?
That's just a buffer for the size of the... oh, yes. So what's the magic number 496 that we have? 4096 that we have there? That's actually just a buffer size. I'm simplifying my code so that I don't have a dynamic buffer. I just allocated 4 kilobytes for the response. That's what that is. So that is one way you could write an IDE communicator in Python to talk to the IDE. Now, this seems pretty straightforward so far. Socket version 1, socket version 2. How do we debug this? Because you're going to run into issues. Well, logging really is your friend. So be verbose when you build your build scripts, because your future self will really thank you. So you want to log the event. There are specific comments. Don't bother with logging the time or anything like that, because the logging frame will take care of that for you. Don't overcomplicate things. Just echo sending to the IDE. Echo what I'm sending to the IDE. Echo reply from the IDE. Things like that, right? Pretty straightforward. This log really is an internal tool. It's not really user-facing, so put as much logging as you want. This is going to be good for your CI system. It's going to help you in the future. Now, I haven't found a good way to debug on Python, because I'm not super expert on Python, but I do know that Ruby has a tool called pry. And what you can do, if you were to write this little IDE connect in Ruby, you could use the gem called pry, and in your Ruby script you'd say require pry, and then at some point in your script you just type binding.pry, and then your script's going to break into the interactive Ruby debugger, interactive Ruby console, so IRB, and you will be able to explore, look at variables, look at the status of things, much like you would in a normal debugger. I believe there's a similar thing that you can do in Python. I just don't know what it is off the top of my head. But in the end, caveman debugging, logging is super useful as well. Now, speaking of results, so in general, your CI systems, they will stop their build when your processes exit or error levels with something other than 0. Like if you exit 1 or 65 or whatever, this will usually stop the CI system and tell it, hey, something bad happened, and the build becomes not built or whatever. So they will also display the last few lines of the log, so it's also able to consume all sorts of unit test results that you might have, like in JUnit format and things like that. Xojo unit, if you're using it, can output this format. But basically, your CI system should be able to display your logs, what happened, the error, and the filter. But since the reply from Xojo comes in JSON format, one handy tip that I have is you can pipe the JSON output from the socket to mjson.tool, and that will print it, which is kind of useful if you're looking at a log to see the full details. So that way you can extract the relevant, command not so much, but the response, yes, and the error that would be eventually there. And I'll have examples of that in a moment. There's really lots of good information that's returned in that JSON reply, so I encourage you to take a look at it, or at the very least log it, even if it's a success, because the data is going to be an error, you're going to have the same thing, right? One interesting gotcha is to handle crashes. So if there's a crash for whatever reason, the socket might still be open. So one thing that I would recommend that you do is before you do a build on your CI system, you run a pre-build script, like a separate bash script or batch file that checks if Xojo is active or not. Or actually, it doesn't care if Xojo is active or not, but it tries to remove any trace of the Xojo processes in memory. So you start with a clean slate. A simple thing would be to, on Linux or Mac, just do kill all Xojo, which will kill any process that contains the string Xojo, which is good on a CI system, may not be so good on your Mac. And then you can just, once you've done that, you can just remove the socket if it was left over. One other thing, I also like to remove any autosave projects. That way you don't have the handy-dandy recovery dialog that comes up if you've crashed in the middle. I think there's a better way that's supported way to prevent autosave, but I couldn't remember it. So somebody's probably going to tell me when we're done with this presentation. But basically, that's a handy tip for me. The one I wasn't able to remove is the upgrade dialog. So if it comes up and you're using an older version of Xojo, because it's your build system and you want to build on a consistent platform, the upgrade dialog comes up might block some of these things. All right, now it's time for comparisons. So I'm going to show you a before and after. The before is Lightspeed 2019.1, which is known as Gilbert, and after is Lightspeed 2019.3, which we know as Master. That's the current version we haven't shipped yet. Modern takes less time to build, so the after will take less time to build, has more verbose output, especially when it fails. It doesn't require terminal scripting for accessibility. It doesn't come to the front. It doesn't add to your recent documents list when you're using Xojo. So overall, it's much cleaner. So what I did is I thought about doing a live demo about this, but it does take time to start Xojo, build the whole thing. So what I did is I captured videos of what was happening, and I will be able to narrate them and hopefully not waste too much time doing that. So let's start with the first one. This is the first. This is building Gilbert with the old style. So you can see that I'm calling my build client.sh. I have a RB build number environment variable I'm just using that as the build number for the client. It's going to be client version 123, and the output is going to be in user share build. So I also pre-built the frameworks. Like the way Onsite is built is we build a bunch of Mac frameworks, then we build Xojo, and we put everything together into one package. So I've pre-built the frameworks just for convenience. So if I click here, this movie should start. I hope it does. And I've trimmed it, so the build should be much faster. There we go. So I just pressed enter. So it started the build. This is the build script, build.rbs. And you can see behind here that it's waiting for the IDE to do its thing. Now, you can see the file menu is up because we scripted the file menu to open the thing. We went to the recent items to find it. We're building for x86-64. We're loading all our plugins. Of course, I've cut the thing for time. It's actually much slower than this. The whole movie was about 5 minutes. Now it's 1 minute, just like trimmed it for you. So now it's all built. It's linking, which also takes a little while, so I trimmed that. And now it's thinking a little bit more. We're still waiting. We're about to quit the IDE at the bottom there. We're copying the artifacts to the output, and we're done. So what you notice there is that the script was behind, the Xojo was in front. All of these things happened pretty much. You could see the UI scripting going. This is essentially the demo that I gave at lunchtime 4 years ago. Now, let's take a look at the modern way of doing things. So you can see that in the new one, we are sending 2 commands. The first one is we're sending a command to the IDE to, well, we're going to send 2 commands. One is going to be open the project, and the other one is going to be build the client. So opening the project, first we need to launch Xojo. So what I did is I just launched Xojo, and I'm waiting for the socket to appear. And when the socket appears, the IDE is ready. And then I can send the open project command to Xojo. And this is opening the project, so it's taking a little while. I'm going to fast forward this, which is what I trimmed last night. There we go. So you can see behind the scenes that the project was open. There's a Xojo window behind. And there's a reply from Xojo that says, your open project command, there was a response. It's project opened. So I'm starting the build, and I'm sending the build project command to Xojo. Now, Xojo is still behind. What you're going to notice is, as I fast forward through this, because you can see the whole movie is 5 minutes, is that there's the bouncy at the right, that Xojo is active, because Xojo is starting to build the project. So the sheet for building is coming down, and that's just the macOS saying, well, there's some activity going on, so I'm a hyperactive child, and look at me. So I'm just going to fast forward through that and make it bounce really fast, because it's building, and that's kind of boring. So here, there we go. So stop here. So there's only a few seconds left. We've sent the build project command to Xojo, and there's a reply. Build succeeded. So now we have all of this verbosity. The IDE never came to the front, and we have the same output at the end of building with Xojo. What happens when there's a problem? In this particular case, I changed one line. This is what this diff is. I made one line. It's called if no duplicates, and I just added an S to it. So I made a typo, right? Intentionally. And this is what I'm showing you here. I'm just going to run the same command, and let's see what happens. So the video. All right. So this is building the IDE with an error using the old style. That's Gilbert. And you can see this is the old style because it comes to the front. Also, I put the terminal as black so I could remember. Everything came to the front, and there's going to be a problem because I added this typo. What's going to happen? We're just waiting for Xojo to exit here. And what's going to happen in this particular case is that we'll see the error in Xojo, obviously, like you would normally. If you press build and there's a problem, you're going to see it in the IDE. But our script will really have no good way of figuring that out. They just say, well, it's hung, right? And then you have to remote into the machine or VNC into it and press the button, which is what I'm going to do here. You can see there's a builds failed, and then there's the typo, but we're still waiting for Xojo to exit. So you'll see the mouse move normally in the video to go and click the button. There we go, because I had to essentially remote into the system, and then I have this little empty build message that's an artifact from an older way of doing things. So in the old way, when the build was hung for whatever reason, a typo or something, a missing library, it kind of got hung, and then your CI system says, this build has been going for 365 minutes. You're like, what the hell? So not super useful for this particular case. But if you go back to the new way, so again, I made a typo. It's blue, so you can see that's the new one. And it's the same command. We're waiting for the IDE to launch. I'm going to fast forward this a little bit because it's It's a little bit boring. We're launched. We're sending the open project. So normally Xojo should come up behind the project should come up behind on that right-hand side here. I made the terminal window maybe too big so you could see it. And there it is. So now my project is open. So the reply was the project is open as before. We're sending the build project command. So again, I'm going to fast forward through the building of the project. You can see the bouncy Xojo at the top. And then it should fail. Or, there we go. So it's building. We know it's going to fail at some point, right? So how is this going to manifest itself? Well, it's going to manifest itself, I hope, by showing inside of the, there we go, by quitting Xojo, because that's the quit is part of the script, but also here's the reply. So if you look at this, you can see that I have a tag, build project, and a response. It's got a build error, it's got errors. Those are all nested, right? So I didn't pre-print this JSON, but you can see that it's got a lot of information there. There's a code, there's a error, it's got type, code, so it's a code error. It's got a message, this item does not exist. There's a source, no duplicates with the S there. There's a location, there's all the information that you would need to find out where that problem is inside of your source code. This is essentially what the IDE uses, I assume, because it's got enough information to do all of this. And at the end, Xojo exited properly, and we copied the artifacts, but it's probably incomplete, and we had a build failure. If you were to run this into your CI system, since the code exited with an error that was not 0, you would get the red build, and it would tell you, oh, this is the error you're looking for. So in the new system, it's a lot better. That's the one with the failure. In the new system, it's a lot better because you get the info you need, the IDE quits properly every time, and you can relaunch the build right after, like, oh, I made a typo, I'm gonna correct this. Commit the typo, push to master, let it builds automatically, everybody's happy, everything works fine. So that's, in a nutshell, the comparison between what we had before for a long time that was getting more and more unstable, and something like this that just uses socket version 2 to talk to the IDE, and that has been rock solid ever since I implemented it in January, so I'm very happy about that. So this is the movie that you saw because I put the wrong movie in, and basically at this point, that's it. If you have any questions, I'll be happy to take them, and please leave some feedback in the XDC app. Greg. So Greg is providing extra information for all of us. The first one is there's an environment variable that you can set, I guess, before you start your build. That's called Xojo_automation. If you set that to 1, I'm going to say, then there's a bunch of things that don't happen, like the crash dialog or the recover dialog and things like that. And the second one is to prevent automatic upgrades. There's a preference in your Xojo IDE that will prevent this dialog from showing up. So you have to go on your CI system and set that up, obviously, because it's not the same as your main machine. So those are the two things. Can that second one be scripted, Greg? The preferences for no upgrades?
I don't believe so, but you
I will file a feedback to make that scriptable, at least some kind of plist or defaults, whatever, something like that. Yes, Jim. So Jim's question is, how does that work in the on-site universe to generate these builds? The answer is we generate as many builds as we need. So the master build is going to happen on a nightly basis. So it just happens at, I think it's 3 a.m. It generates a master build. The master build is there because it's got both the server and the client, so this full installer. Doesn't take that much time. I think it's 25 minutes to build. The client is about 5 minutes out of that, so that tells you an idea of the rest that we need to build. The client build itself can happen at any time. If you create a branch in your version control system, you can set your CI system to watch for branches and run any script you want. So that's what we do. For example, let's say I'm working on a bug in the client, and I would like QA to be able to test it. Well, when I fix the bug, I make a branch that's got the bug name or something and the ticket that I'm working on, and I'm committing my changes there. And when I push that to the version control system, the CI system watches that and says, hey, you made a branch. Let me make a build for you. So that it automatically generates a client build that's got the same branch name as the one that we just created. So on the one hand, I can send this code to peer review so Yves can take a look at it. And on the other hand, by the time hopefully Yves is done with his review and he has approved what I have done, or not, it happens, there's a build that's ready for QA to test. So I don't have to hand them over anything. Like, this was built on my machine, go and test this. No, they can actually take whatever came out of the build system and say, yes, we can verify that you fixed this. And when QA has verified that my branch is correct and Yves has approved the quality of my code, I can merge that into master and it'll be part of the next master build. The idea being that on the next master build, when I say to fine, the QA has said it's okay, Yves has said it's okay, I can merge this to master. I consider this bug resolved. And when it's resolved, it goes to QA. And QA gets all these resolved bugs and says, all right, we think this one is resolved, let's check master. And then, is it resolved in master? Yes, we close it. So that's essentially the process. So if you use build automation like this, you will create many more builds and artifacts, which is very useful if you want to do things that are temporary or not always committing to master, right? Because master is considered by many to be the canonically always shippable state, right? Whereas if you have branch builds, it's very handy for both short and longer term things that are maybe experimental or that need extra testing or things like that. Every time we have like a new version of Xojo, for instance, you saw that we were building with 2018.3 still for QA reasons, because if we change the version of Xojo, we essentially change everything. Like, QA has to retest everything. So we move to the next version as soon as we can, but we have to respect QA. So whenever I do that, I will do it on a branch, and I will make sure that everything builds on a branch, because you can have multiple versions of Xojo on your system, even on your CI system, and I will generate some builds off of the new Xojo and tell QA to test it, because I'm testing it, and then they're testing it, and when everybody's happy, then we merge that to master and it becomes the new truth that we're about to ship. Greg. So the question is, how long do we keep build artifacts? Build artifacts are kept on master. I think we keep the last 25 of the nightlies and anything that we've tagged with the label release. So your CI system might allow you to put a little label next to a build output. And in our case, if we put the label release, then it means that this artifact should not be deleted. So we'll keep that for as long as until the end of time, essentially. And for anything that's in a branch, well, branches are typically deleted when they're merged. So we have a branch, like I do a feature or I do something experimental, and if it's experimental and it's never going to ship, when I delete the branch, all the artifacts are gone. But if it's a feature and it's got multiple commits and lots of work and it took 2 weeks or whatever, when we merge that branch in, the branch is deleted and again the artifacts are gone. So I think it's 25 that it's being set at. So we can go back to a few back and things like that relatively easily. Okay, question is, can I expect what an artifact is? So when you run your CI system and it runs all these fancy scripts and generates, you saw them at the end of the movie here, it said copying client build artifacts. So what it does is you have your, in my case it's lightspeed.app, so it's an app package that we then compress using zip, so that makes one zip file. And the CI system knows to look for star.zip in a certain folder, and it will copy that into its main repository, because your CI system is likely not running on a Mac. It's probably running on some Linux variant somewhere, and your Mac is just a client of it. You need the Mac obviously to build with Xojo in my case, or a Windows machine to build with Windows, but that's just a client of the CI system. It's an agent, as they're called. So this agent has this zip file in a certain known folder, and the CI system in the cloud knows to ask the agent, hey, is there a zip file in that folder? If yes, upload it to me. And the CI system in the cloud will keep that artifact zip file or whatever into your cloud system. This is also valid if you have like unit test results, for instance. They would be an XML file. Or if you had any kind of logging that you wanted to keep, extra logging, that would also be there. So our system is set up to keep it for about 20, I think it's 25 builds artifacts, but your system may vary. Some keep them forever, which is probably a waste of disk space, but yeah, your system will vary. Yes, Dirk. That's a very good question, which is how do we integrate the build with the unit tests? So the unit test script, which I have not gone through here, is essentially the same as the build script. The only difference is we will modify the project file, which is just a text file. We modify it to add just one constant that says you're building unit tests. So the artifact that it generates is the unit test artifact. So it's the same app, only it has a few more frameworks like Xojo Unit and things like that. And the idea is if you were to launch this app manually, it would open up and it would have the unit test dialog, run the unit test dialog, and generate an XML file for the results. So it's the exact same script with one tiny modification. I didn't go into those details here, but essentially having it's not a duplicate of the script, it's the same script with an if-else statement at a very specific spot. And that will generate a unit test artifact, which is just the app. And the next step in the build system is not to archive the artifact, it's to run the artifact and then get the unit test result out of that. So that's pretty straightforward, and the advantage is it works exactly in the same way, and we can generate the results in the same amount of time. Typically we have, I think it's 4 build plans going. So you have the client build plan, the client logic tests, the client unit tests, and so the logic tests are kind of all the model frameworks that we use on Cocoa, and then the unit tests are these. And there's another one. I think it's the install unit tests. Anyway, there are multiple plans, and we have multiple agents, so they run simultaneously, and it's fast and it's fun. Yeah, if you can have multiple agents, that really helps. Otherwise, it just queues up things one after the other. Eve, I would say at least 2. Oh, the question is how many build agents are useful? Well, at least 1, obviously. If you don't have 1, you can't do anything. The more, the merrier. There are ways to virtualize some of them, and I'm looking into them. Like you could have, like, say, a Mac Mini that runs VMware Fusion, that runs 2 or 3 instances of Mac OS and VMware Fusion. They could all be separate images. That works up until, I think it's High Sierra that didn't virtualize really well, in terms of the performance was atrocious. And since Xojo has a GUI and it needs to display and things, that took the performance down. So we went on real hardware. And right now we have 2 Mac Minis that are running the build system. So you can have 2 concurrent builds, and that's relatively fast. Dirk. The question is, which CI do we use at the moment? We use something called Bamboo by Atlassian. It's very similar in concept to Jenkins with the way that it works and things like that. It's a commercial product. I think we use it because we use all Atlassian all the time, like a lot of people. But if you wanted to start, I will refer you to my talk from 2 years ago, where I displayed the usage of Jenkins at XDC in 2016. Jenkins is free and does pretty much all the things you need to do to build this. I think Xojo uses Circle CI, if I'm mistaken. Build. GoCD, yeah. GoCD is what is another one, the one that's being used by actual Xojo. So those are cloud offerings as well. So, Dirk. The question is, what if we had Jenkins 2 years ago, why did we switch? Actually, we never switched. I used Jenkins for the demo because I knew everybody could get Jenkins for free. So we were using Bamboo at the time. Yeah. But the logic is exactly the same between the two, so it's super easy for me to port.
So how many developers do you have?
The question is, how many developers do we have? Do you mean for the on-site project or in general? For the on-site project, you're looking at them in this room. It's Eve and I. We have 2 back-end developers as well. So they develop the other part of the system, that's the server that I did not show you here, but it's also part of the main build system. It's part of the installer and things like that. Yeah. I hope you found this useful. As I said, the slides and the real movies, I will fix that before I give you the slides, and all the scripts that I showed will be available as I will make sure that Dana has them. Thank you.